Assalamualaikum and greetings to all of you. My name is Muhammad Harif Farhan bin Muhammad Azizan. My matric number is DE230061. I will be presenting the task 1, which we need to find the V1 and V2 using the nodal analysis and finding the I1, I2, I3 and I4 using the mesh analysis. So let's get through to it. Okay guys, this is the solution to find V1 and V2 using the nodal analysis. The first thing you want to do is draw back the circuit and find the current flow. Okay, as you can see, there are two current sources, which the current from the 2 amp and the current from the 4 amp. So next, we want to identify where the current goes into the node V1 and where the current is exit the node V1. From the circuit, we have two that goes into the node V1, which from the left you have current from the 2 amp that goes into the node V1, and from the right we have current from the 4 amp flows and goes into the node V1. Okay, from this we identify the current from the 2 amp and the current from the 4 amp entering the node V1. So we label it as I1 and I4. So what's the current that exiting the node V1? So as the current in, there will be a current will exiting the node V1. From this, there are two current that will distribute to the other junction. As you can see, we have current that exceeding the node V1 to the resistors and the power source, and also we have a current that goes to the 2 ohm resistors. So we can label it as I2 and I3, which these two current are exiting the node V1. Okay, we got all the information where the current in and out, so we can solve. And the first equation using the current in equals to the current out. So the KCL refers back to the voltage formula, which we move the I, we get I equal to V over R. So in KCL, it actually tells we need to subtract the V higher minus by V lower and divided by the resistance. So from this, we get I1 which it tells us this is the current, the value of the current, I2 plus, so from the I4, so the current, entering the V2 first, so the V2 are higher than the V1, so we write the V2 minus V1 equals to 4. The current that across the resistance. Okay, we got the first equation. Next, the current out, we've got the current that across the resistors and power source, which the V higher, which is the V1, will across the 4 volt, which it enters the power source. So we plus by 4 and minus by V2. So V2 is the V lower, and we will be, so the resistors will be 1 plus 2 because the current are entering, so the resistors will be added because this circuit above is in series. So in series circuit, the resistors are connected to each other. So we add 1 ohm and 2 ohm, we get 3 ohm. And lastly, the current flow out from the V1, which it goes below. So we get V1 over 2. So if we can simplify it, and we get the first equation, which is negative 13 V1 plus 7 V2 equals to negative 8. So this is our first equation. Okay, let's go to the second equation. Same goes to the same situation that we explained in the node V1. We need to find where is the current in and the current out. So from this situation, which current that entering the node V2? Okay, we recap back from the node V1. The current that exiting the V1, which the I2 will enter the node V2. So from this, we know the I2 and I6 are entering the node V2. And what current that exiting the node V2? Okay, from the current that from the 4A, which I6 is entering, and there will be a current that exiting the node V2, right? The current that exit the node V2 are the I4, which earlier we marked this as I4, the entering the node V1. But in this situation, the I4 will enter the V2 first, and then it exiting the I4. So the I4 earlier are exiting the V2, and next the current which I2 that enter the node V2 will be exit from the junction, and we label it as I5 because we want to avoid confusion from the I2. We label it as the new current, which we label it as I5. So from the current, I2 will exiting the node of V2, and will cross the resistor 3M and will go to the ground. So the current that exiting the node V2 are the I4 and the I5. So from this, we can do the same step from the node at V1. We can get 7 V1 minus 11 V2 equals to negative 64. Okay, from this we already get the two equation. The equation node at V1 and the equation from the node V2. So we move to back. From this, we can do matrix to solve the equation by finding the V1 and V2. We can press the calculator. So we can get V1 equals to 5.702 volt, and the V2 is equal to 9.447 volt. So this is the solution to find V1 and V2 using pin nodal analysis. Okay, this is the solution to find I1, I2, I3 and I4 using mesh analysis. So the first thing we're gonna do is draw the circuit. Next, we gonna find the loop in the circuit. So as you can see, we already have 4 loops. The first loop is this one. The second loop, the current that across the 2 ohm, 4 ohm and 3 ohm. The third loop is the current across 2 amp and 2 ohm, and the last one is the current that across 5 ohm, 4 amp and 3 amp. Okay, now we already know the loop. Now we can go and find the I1, I2, I3 and I4. But before we move on, we just already got the value of the I3 and I4. As you can see, the I3, the current that across 2 ohms are the same. As you can see, the current that through 2 ohm is in series, so we can assume that current that because we can assume that current that through 2 ohm is the same value, so we get I3 equals to 2 amp. And another one is I4, the current that across the 5 ohm and 3 ohm are the same current, so we can assume that I4 is 4 amp. Now we only have to find the I1 and the I2. Okay, for the equation of I1 is 1 ohm, which we just put the I1 plus current across the 2 ohm, which we write 2I1 and 4 ohm. Okay, you need to know that there has a current overlap in this resistor, which there is current I1. At the same time, there is a current I2. Now, by related to the KVN, I higher will be subtract by I lower, then it will be times by R. Now we will take the value of the resistor, which is 4, will be multiplied by I1, which is it is higher, then we minus it by I2 because I2 is lower than the I1. Okay, now if we simplify the circle, we've got 7I1 minus 4I2 equals to 4. So this is the first equation. Now let's go to the loop number 2, which is loop I2. As you can see, the situation in the loop I2 are the same situation that we explained during we find the current in the I1. So in this case, I2 is higher than I3 and I4. So we just put the value, which is 4 multiplied by I2 minus I1 plus 2, which is this 2, will be multiplied by I2 minus I3. So we just take the value of the I3, which is 2M, into this equation now, plus 3 multiplied by I2 minus -4. So why the value of the I4 becomes negative? Because we assume the current flow like this, clockwise. But according to this current source, the current flows oppositely from that we assume. So the value becomes negative if we use this assumption. Okay, understand? Then if we simplify the circuit, we will get negative 4 I1 plus 9 I2 equals to negative 8. So we already got the two equation. Now we will do the matrix to solve an I1 and I2. Okay, if we simplify by using the calculator, we will get I1 is 0.085 m, I2 is negative 0.851 m, and the I3 is 2m and I4 is 4m. But from the circuit, you can see 2m is distribute the current from the current source to m, so also distributed in this loop. So from the answer, we've got negative. So the assumption is the current flows oppositely. Then if the current flows oppositely from the assumption that we made, we must add the 2m to get the answer for the I2. So the I2 is negative 2m equals to negative 2.851. So we already got the answer. So that's all from me. Thank you for watching and see you guys later.
Hi, my name is Guganesh Alakis Sudhiri, metric number DE230114, and I'm going to be presenting for about task 2 simulation. So this is the simulation I've done, where I've used multi-sim software, and using this circuit that I've built here, and I've placed probes to find out the values for V1, V2, I4, I1, I2 and I3. So when we run this simulation, we could see the values over here. So for I4, the value is 85.1 milliampere, I1 is 2 ampere, I2 is negative 2.85 ampere, and I3 is negative 3.15 ampere. As for the voltages V1 and V2, V1 is 5.7 volts and V2 is 9.45 volts. So that is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Remy Isa with numeric DE230059. I will explain about the task 3, part 1. First, we can get the voltage source from the 2 ampere independent current and 16 ohm. So 2 multiple 16 is 32, and in a series circuit we get 32 volt and 8 volt. So negative 32 plus 8 same with negative 34 volt. On the right side of the circuit, parallel resistor 6 ohm and 3 ohm. After we calculate, we get 2 ohms. And back to the left side, resistor in series 16 ohms and 20 ohms. We add, we get 36 ohms, and we conclude with parallel 36 ohm and 12 ohms. After we calculate, we get 9 ohms. For the I, we got 34 divided by 36, and we get 2/3 ampere from the current source to voltage source. So the V1 is 2/3 multiple with 9, we get 6 volt, and V2 3 multiple with 12, we get 36 volt.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mahir Adab. My matrix number is DE230126. I will be presenting the KVL for part 3, task 3. So after the calculation, the KVL should be -6 plus 9i minus 36 plus 12i plus 7i minus VO equal to 0. VO will be equal to -6 minus 36 plus 28i. So I equal to 5/2. VO is equal to -6 minus 36 plus 28. We insert the value of I, which is 5/2. So VO is 28 volt. That is all from me. Thank you.